Welcome. In the last lecture, we have seen some theory of block diagram, how to determine that transfer function, that is Cs upon Rs. Now, today we will discuss some rules of block diagram reduction. Any complicated system, if brought to its simple form of canonical form, its transfer function can be calculated by results as obtained previously. To bring it into simple form, it is necessary to reduce the block diagram, but using proper logic such that output of that system and the value of any feedback signal should not get disturbed. This can be achieved by using following mathematical rules while block diagram reduction. Now, rule number 1, associative law. Consider two summing points as shown in figure. Now, these two summing points are there. At first summing point, signal, positive signal R1 is there, negative signal minus R2 is there. Therefore, from this summing point, the resultant signal is R1 minus R2. It is fed back to this second summing point. At the second summing point, again two signals are there. This R1 minus R2 first signal and plus R3, that is second signal. Therefore, the output from the second summing point is R1 minus R2 plus R3. Now, what this associative law says, you can interchange the position of the two summing points. Still, the output must remain same. Therefore, provided that there should not be a block in between the two summing points, the two summing points should be directly connected with each other. Therefore, now change the position of the two summing points as shown in figure below. Therefore, at first summing point again, this summing point, second summing point will go to the first summing point, and first summing point will go to the position of second summing point. Therefore, this at second summing point will become first summing point will become second summing point. Therefore, now again here at this summing point, R1 signal is there, that is positive. Then again another positive signal is there, therefore that is plus R3. Therefore, output from the first summing point is R1 plus R3. It is fed back to the second summing point. At the second summing point again two signals are there, that is R1 plus R3 and this minus R2. Therefore, output from this summing point, that is second summing point, is R1 plus R3 minus R2. Therefore, by comparing these two outputs, this output and this output, we are observing that the output remains same. That is, by interchanging the position of two summing points, the output remains same, provided that the two summing points should be directly connected with each other. There should not be any block between the two summing points. Now, some cases are there. Consider summing points with a block in between as shown in figure below. Therefore, this at this summing point plus R1 signal is there, then minus R2 signal is there. Therefore, output from this summing point is minus R1 minus R2. Then this block G1 is there. Therefore, R1 minus R2 into G1. Again, this signal is fed back to the second summing point. Then here plus R3 signal is there, and this signal R1 minus R2 into G. Therefore, output from this summing point is R1 minus R2 into G plus R3. Now, we will interchange the two summing points, and we will see that whether output remains same or different. Therefore, we have interchanged, and it is shown in the figure. Here again signal R1 is there, positive signal R1, then positive signal R3. Therefore output from this semi point is R1 plus R3. Then this block G is there. Therefore from this output from this block is R1 plus R3 into G. Again it is fed back to the second semi point. Therefore at second semi point another signal is there, that is minus R2. Therefore output from the second semi point is R1 plus R3 into G minus R2. Therefore by comparing these two outputs, we are observing that output does not remain the same. That means to follow the associative law, or if we want to apply the associative law for the two summing points, the two summing points must be directly connected with each other. There should not be any block or any takeoff point between the two summing points. Takeoff point is also known as feedback signal or feedback point. Now rule number 2, blocks in series. The blocks which are connected in series get multiplied with each other. Consider a system as shown in figure below. Now this input signal R is there, this block G1 is there, block G2 is there, and block G3 is there. These blocks are connected with each other. This CS is nothing but controlled output. Now from this block G1 output signal is RG1, from this block G2 output signal is RG1G2, and from this block G3, that is controlled output, that is last output, CS is equal to R into G1G2 G3. Therefore when the blocks are in series, these blocks are getting multiplied with each other, and the resultant block diagram is shown here. This input R is there, then this single block is there having its transfer function G1 into G2 into G3, and this control output C is there. Therefore control output CS is equal to R into G1 G2 G3. That is when the blocks are connected in series, these blocks are getting multiplied with each other. This is the rule, provided that there should not be any takeoff point or summing point between the blocks. The blocks should be directly connected with each other. If there is a takeoff point or a summing point in between the blocks cannot be said to be in series as shown in figure below. Therefore we just check it. This is the input signal, then this G1 block is there, it is connected to G2 block. In between G2 and G3 this takeoff point is there, or this feedback signal is taken off. Now we will see this, since these two blocks are directly connected with each other, therefore these two blocks will form one block, that is G1 G2. Then this takeoff point is there in between the two blocks, that is G3. In above combinations, blocks G1 and G2 are said to be in series and can be combined as one block, that is G1 G2, but G3 is not in series with G1 and G2 because in between G1 G2 and G3 this takeoff point is there. Now blocks, rule number 3, blocks in parallel. The blocks which are connected in parallel get added algebraically by considering the sign as discussed below. Therefore this reference input R is there, it is equally fed back to the blocks G1, G2 and G3. Therefore output from the block G1 is RG1, output from the block G2 is RG2, output from the block G3 is RG3. Now signal from G1 is negative, signal from G2 is positive, signal from G3 is positive, and all these three signals are coming at one summing point, and this is control output C. Therefore control output C is equal to, you can write, minus RG1 plus RG2 plus RG3, therefore which is equal to C is equal to R into bracket G2 plus G3 minus G1. Therefore you can write this C is equal to R into bracket G2 plus G3 minus G1. Therefore R into this block G2 plus G3 minus G1 is equal to C. Therefore when the blocks are connected in parallel, they are getting added algebraically by considering the sign. This is the rule number 3. Now consider this case. In this diagram it is seen that, or it is seeing that these two blocks are in parallel, but it is not like that, because there is a takeoff point. There is a takeoff point in between block G1 and this summing point. In between this block G1 and summing point. Therefore, unless and until this takeoff point is shifted before the blocks cannot said to be in parallel. Therefore, these two blocks are not in parallel because there is a takeoff point between block G1 and this summing point. Summing point is represented by circle. Again, consider second case. This is the summing point. At the summing point, this input signal is coming. From the summing point, this output signal is given to the G1. From G1, this output is there. Again, here signal is taken off. Again, it is fed back to this G2, and again signal from G2 is fed back to the summing point. Therefore, here it is observed that, or it looks like that blocks G1 and G2 are in parallel, but it is not like that, because directions of the signal coming from G1 are from left to right, and directions of signal coming from G2 are from right to left. Therefore, always remember, for a parallel combination, the direction of signals through the blocks in parallel must be same. That is, the direction of signals from the blocks must be in the same direction. Then and then that blocks are considered to be in parallel. Now, rule number 4, shifting summing point behind the block. Now consider this diagram. This input R is there, it is given to this block G, therefore signal RG is there. This signal RG is given to this, or it is fed to this summing point. Again at the summing point another signal is there, that is plus Y. Therefore from the summing point output C is equal to RG plus Y. Here output C is equal to RG plus Y. Now what we have to do? We have to shift this summing point behind the block, means behind this block. Now while shifting the summing point behind the block, the output must remain same. The output must remain same. Therefore, first of all, we will shift it, and again we will rearrange the block diagram. Now here, same diagram I have drawn. RG plus Y, C is equal to RG plus Y. Now what we will do? We have shifted this summing point behind the block. We have shifted this summing point behind the block. Now you just see here what will be the output. Here at the summing point two signals are there, plus R and plus X. Therefore after summing point the signal is R plus X. Again it is given to this G. Therefore control output C is equal to R plus X into G. Therefore here output C is equal to R plus X into G, that is C is equal to RG plus XG, equation 2. Now comparing equation 1 and 2 we get, this is the equation 1, C is equal to RG plus Y, and equation 2, C is equal to RG plus XG. Therefore we are getting XG is equal to Y, or X is equal to Y upon G, equation 3. Therefore what is the value of X signal? Y upon G. That is, the signal Y must be multiplied with 1 upon G to keep the output same. Therefore we will modify that diagram. Whatever this diagram is there, this diagram will modify. Again this signal R is there. Again at the summing point what we have done, or what we have said, a block of value 1 upon G must be added in the signal Y. Therefore this is the signal Y. In between the summing point and signal Y we have to add a block whose value is 1 upon g. Therefore now r plus y upon g. Again this signal is fed to this block G. Therefore r plus y upon g into g. Therefore rg plus y. Therefore C is equal to rg plus y. That means output remains same. Therefore what we have done? If we have to shift a summing point behind the block, we have to add a block having its value reciprocal of the value of that block. See that earlier summing point was here, we have shifted here. Therefore we have added a block having reciprocal of the value of the block. Here value of the block is g, and here we have added a block having its value 1 upon g. Thus while shifting a summing point behind the block, or that is before the block, add a block having transfer function as reciprocal of transfer function of the block before which the summing point is to be shifted in series with all the signals at that summing point to get the desired output without change. Therefore you just see here we have added a block having its transfer function means value of that block, or value inside the block. Therefore earlier value inside the block was g, now value inside the block is 1 upon g. Therefore we will stop here. Another 4 rules we will see in the next lecture.